Okay, our last lesson for this module is going to be lesson 30, applications of the loanable funds market. And really all we're going to do here is take a look at a few free response questions to make sure that you're comfortable with the answers. We're going to start with the AP problem number 2 from the 2007 Form B exam. It's one of the problems that I assigned to you in this module. Hopefully you've had a chance to look at this problem already, and we'll just be reviewing it now together. Let's take a look first at Part A. Part A says, assume that businesses are granted a tax credit on spending for machinery. Using a correctly labeled graph of the loanable funds market, show the effect of the business sector's response on the real interest rate. Okay, well, we have a few things to consider here. The first thing is this word here, which is kind of an interesting phrase that we don't necessarily talk about explicitly in this course, but it's good to understand what it means. A tax credit is essentially when businesses get a discount on their taxes for doing something. Homeowners, for example, a few years ago got a credit for buying new houses, which means their taxes were reduced by a certain amount because they did something the government wanted them to do. In this case, they're saying, we're going to give you a tax credit. We're going to give you essentially a gift for spending on machinery. Now, the other thing we should notice is that we're talking about spending on machinery. That most likely is going to fall into the category of investment, specifically investment in capital. So since that's true, we know it's going to affect the loanable funds market. And what is it going to affect? Well, since we're talking about investment in capital, we're probably talking about a change in the demand for loanable funds. And so the answer, I believe, should look like this. Okay, here's our graph. Again, we'll notice a correctly labeled y-axis with a lowercase r, a correctly labeled x-axis, and because of the increase in investment in machinery, thanks to that tax credit, demand is going to increase for loanable funds, which means the real interest rate is going to rise, as we demonstrate right here. Double check your answer and make sure you're comfortable with what we've got here. All right, now let's move on to Part B. Part B of the question says, now assume instead that the tax rate on interest income from household savings is lowered and there is no change in the government's budget deficit. Let's start with the first part of that sentence. Assume instead that the tax rate on interest income from household savings is lowered. All right, this is a little bit of a strange question, but one of the things the government often taxes, in fact always taxes, is any income you make on interest. Interest, for example, if you have a savings account, you get a small amount of interest each year, and technically that's income, and the government can tax that. What the question is saying is, assume that the tax rate on that interest is lowered. What are people more likely to do if the tax rate on the interest they'd be earning on their savings is lowered? Well, the odds are they'd probably be saving more money. And as soon as we hear that, we should think the loanable funds market. And what does it tell us again? Using a second correctly labeled graph of the loanable funds market, show the effect of the household's response on the real interest rates. Since I heard the word savings, I should be thinking the supply curve. And that's what we have here in our answer. Again, a correctly labeled graph. Because savings will increase thanks to the lower tax rate on interest income, savings will increase, which means the supply of loanable funds will increase, which means the real interest rate will decrease. Okay, let's move on to another question now. This time we'll be doing 2007 number 2 instead of 2007B number 2. Okay, so it starts off with a statement that says, in recent years, the Fed has made targeting the federal funds rate a main focus of its monetary policy. The first thing it asks to do, Part A, is define the federal funds rate. Well, there's not much to discuss here. This is sort of just a definition. Hopefully you'll recall that it is the rate at which banks lend to each other. And again, for this question, folks, I'm hoping you've already attempted this question that was assigned to you in the lesson, and this is sort of checking the responses that you gave. Okay, so that was a simple definition. Remember, the federal funds rate is the rate at which banks lend to each other, not to be confused with the discount rate, which is the rate at which the Fed lends directly to banks. Okay, now part B of the question. If the Fed wants to lower the federal funds rate, what open market operation would be appropriate? Okay, well, they want to lower interest rates, specifically the federal funds rate. And how do we do that? Well, we want to increase the money supply, but specifically they tell us we can't just use any old tool. We can only use open market operations. This is review, but hopefully you remember that means the buying and selling of bonds. And since we want the money supply to increase, it means we will buy bonds. That's really pretty much the only answer. Not a lot to discuss there. Okay, let's move on to part C. Part C says, assume that the open market operation that you had indicated in Part B is equal to $10 million. So we're going to buy $10 million worth of bonds. If the required reserve ratio is 0.2 or 20%, calculate the maximum change in loans throughout the banking system. Okay, again, this is a little bit of review, but this is using the money multiplier. So the money multiplier, remember the multiplier is equal to 1 divided by the reserve requirement, or 1 divided by 0.2, which is equal to 5. We then take the amount that was spent, in this case 10 million, and multiply it times the multiplier, which means 10 million times 5 equals 50 million. And remember, the original amount should not be subtracted from the final total, since this money was newly deposited and not previously in M1. This was money that came from the Fed, so it was not previously in M1. Therefore, the answer remains at 50 million. That's pretty straightforward and a review. All right, moving on to Part D. Part D is pretty straightforward. It says, indicate the effect of the open market operation that you indicated in Part B on the nominal interest rates. All right, well, we know, as we've gone over many times now by this time, when you buy bonds, you increase the money supply, and an increase in the money supply means that nominal interest rates will decrease. And that is pretty much the answer. That's, again, quite a bit of review, so we won't spend a great deal of time on that. Lastly, let's go to Part E, which is really the focus of this particular lesson. Okay, Part E says, assume that the Federal Reserve's action results in some inflation. What would be the impact of the open market operation on the real rate of interest? And then explain. All right, well, to understand this question, we need to remember what the term real means. So let's get a little bit of some background here. First, the open market operation causes nominal rates to fall. That's the first thing we should remember. We already noted that in Part D. But nominal interest rates are falling. Now, this is the formula that we would normally use to calculate nominal interest rates. Nominal interest rates are equal to the real interest rate plus the inflation rate. So what this really means is if the left side of this equation is decreasing, and in fact we know it is because we learned that in our last part of the question, that nominal interest rates are decreasing. That means that if the inflation rate is increasing, the only thing that real interest rates could be doing is decreasing. That's just an algebraic way of looking at this. Another way to think about this, though, is this, and this is really the explanation. Remember that real interest rates are not affected by inflation because we don't consider inflation with real interest rates. We only consider it with nominal. So if nominal interest rates are coming down, even though inflation is rising, we know that real interest rates must be decreasing. And here's how I worded it. If nominal rates are decreasing and inflation is increasing, real interest rates must be decreasing. And again, the key point being because inflation doesn't affect real interest rates. So you can either explain this question algebraically by using that formula and simply saying, listen, if the left side of the equation is decreasing and one of the two things being added is increasing, in this case the inflation rate, it must be true that real interest rates are decreasing. Or you could simply point out that real interest rates are not influenced by inflation. So if nominal rates are dropping, real interest rates must also be dropping, even if inflation is rising. Okay, there's a few other problems for you to try on your own. Hopefully this gave you a good summary and some good answers to your practice.